All right, so we're gonna do 2, 3, 1 today. Make sure those learning strategies, the first round of those, and then your college homework that's on Canvas, your Unit 2 Part 1, that's all due today. So make sure that's getting done. When we come back on Monday, we're gonna have a homework check on homework 221, 222, 223. So this one's not going to be included in it because I want to get a chance to answer questions on Monday. But again, make sure you're getting all that stuff done. Make sure you're getting that quiz done. So we have a lot of stuff to make sure we're getting done before you guys come back on Monday. Okay. Remember, test, we're going to try to have that next Thursday and Friday. So keeping that in mind too. Okay, so today we're talking about composition of functions. That's another thing. We should have covered it in Algebra 1, but we probably didn't cover it in depth, and I know that that's been a while. So a composition function is taking one function and inserting it into another function. So you're still going to have, like on this mapping diagram, you're still going to have your x values are your original inputs, okay? So you're going to take that and you're going to input it into the function, whatever that function is. And then when you do that, you're going to get an output. So like in this one, when we put 1 in for x to this function, we got back 2. When we plugged in 2, we got back 4. 3, we got back 6. All right. And then the big thing about composition is the output of your first function is going to become the input of your next function. So we plugged in 1, we got 2, and then we're going to take 2 and we're going to plug it into our other equation and see what we get back. So now when we plugged in 2, we got 4. When we plugged in 4, we got 16. Plugged in 6, we got 36. All right. So that's kind of what we're going to be talking about. It gives you an example. So it tells you h of x is equal to the square root of x cubed plus 2. If we were to decompose, so take those two apart, all right, your inner function is this part right here. So we could say that our inner function, g of x, is equal to x cubed plus 2, which is what it says down here. And then your outer function is the operation that's happening across the whole entire thing. So your outer function would be the square root of x. And so when you're composing, you're taking this whole inner function and you're plugging it in and seeing what you get. So you end up getting that. Now the big thing is when you're seeing this notation, you're always starting inside working out. So this is saying you're taking G and plugging it in to F. This one's saying you're taking G and you are plugging it in to F. All right. So we're going to go through, I'm going to kind of work through the different problems so you can really see what we're talking about. I'm going to go ahead and I'm actually going to start down here at 4, 5, 6, and 7 so you can get the idea of what we're talking about. So on 4, it's telling you it wants you to take 3 and plug it into G. Then once you get that answer, you're going to plug it into F. All right, so we're going to take 3, x equals 3, and we're going to plug it into G. So when I plug that into G, I get 2. Okay, so now 2 becomes your input. When I'm taking 2 and plugging it into F, I'm getting 5. So it's kind of like a puzzle. You're gonna have to go piece by piece. So this one, we're taking 5 and we're plugging it in to G. So when we take 5, when we plug it into G, we're getting 8. So now 8's becoming our input. When we take 8 and plug it into F, we're getting 2. All right, I encourage you to pause the video, try to do 6 and 7, and then come back and check. So when you come back, now you need to pay attention. Now these ones are the opposite. So now this is telling you to take 6 and plug it into F. So 6, if we plug it into F, we're getting 7. And then we're going to take that value, 7, and plug it into G and get 11. So this next one, we're going to take 3 and plug it into F. So 3, we plug it in, we get 2. We're taking that value, 2, and plugging in a G, and we're getting 6. All right. Okay, so now we're gonna go ahead, we're gonna work through kind of piece by piece. So we're gonna start by looking at number 1. So for number 1, this is talking about a word problem. I think the word problems are probably the hardest ones for you guys to kind of like decipher. Sorry, I'm just gonna flip my screen around. Maybe I'm not. So on this one, it says, suppose C of P gives the number of calories burned by doing push-ups, and P of T gives you the number of push-ups a person can do in T seconds. So it's telling you to take your P of T equation and you're plugging it in for that first equation. So this is giving you C of P of T. And I'm plugging in the number 45. So 45 is your T value. So what this equation together would give you, it would be that in 45 seconds, what is your ultimate output going to be? So when you plug it in to this, you're getting the number of push-ups. And when you're taking the push-ups, you're plugging it in and you're going to find the number of calories. So this is saying in 45 seconds, how many, many calories will be burned. So understanding what that first input is and understanding what your final output's going to be. All right, then for question 2, it gives you 2 different functions. So it's giving you G of T and it's giving you H of T. The first one it wants you to find is G of H of 5. So it wants you to find G of H of 5. So that means we're taking this 5 and we are going to plug it in to our H equation. So we're going to do 3 times 5 plus 2. So that's us plugging it in. We end up getting 3 times 5 is 15 plus 2 is 17. So now we are taking that 17 and we are plugging it in for G. So now you're going to get 17 squared minus 17. So 17 squared is 289 minus 17 is going to give us 272. That would be your final answer. So when you plug in a number, you should get a number back. Part 2 is asking you to just find what the generalized equation is going to be. So if we're looking at part 2, it wants to find G of H of T. So it wants G of H of T. So it wants you to take this whole entire H equation and plug it into your G equation. All right, so your G equation let's just write them down so we have them, is t squared minus t. Your h equation is that 3t plus 2. So we're taking this whole equation and we are going to plug it in anywhere we have a t value in this other equation. So it's going to end up being 3t plus 2 squared minus 3t plus 2. So we just plugged it in for each one of those variables. Now, the big thing now is where we get into the algebra. Like, you have to be able to multiply these out. You have to be able to solve. So this, we cannot take this squared and just distribute. This is the same as saying 3t plus 2 times 3t plus 2. So you have to multiply it out either using the boxes, using the FOIL method, whatever works best for you. This negative is going to get distributed, and we're going to have minus 3t minus 2. So now you need to multiply this out. 3t times 3t is going to give us 9t squared. 3t times 2 is going to give us plus 6t. 2 times 3t is going to give us plus 6t, and 2 times 2 is going to give us 4. And then we still have this minus 3t minus 2. Now you're just combining together like terms. So our final answer, g of h of t, is going to be equal to 9t squared, positive 6t minus 3. So 12 minus 3 is going to give us plus 9t. And then we have plus 4 minus 2 is going to give us plus 2. This would be your final answer. Okay, I'm just going to readjust my... Okay, so composition, you definitely, like, there's a lot of work that goes into them. So again, for question 3, I really, like, try to work through it. See if you can write them both directions. Come back, check your work. All right, so question 3, the first part, A, is asking you to do f of g of x. That means take your g of x equation and plug it in to your f equation. So I'm going to write them up here. Your f of x is equal to x squared minus 3, and your g of x is equal to the square root of x plus 3. Okay, so for this first one, we're taking this whole equation and plugging it in for x over here. So we're going to end up getting the square root of x plus 3 squared minus 3. And then you need to break it down. So if I'm squaring a square root, the square and the square root are going to cancel. And I'm going to get x plus 3 minus 3, plus 3 minus 3, those cancel. And so f of g of x is equal to just x. This is a special kind of composition. And then part B asks you to do it the other way. It wants g of f of x. That's taking your whole f of x equation and plugging it in to g. So we take this whole equation and we're going to plug it in here. So we're going to get the square root of x squared minus 3 plus 3. Plus 3 minus 3, those are going to cancel. So I have the square root of x squared. Square and a square root, those are gonna cancel, and I'm just gonna be left with x. So g of f of x is equal to x also. Again, this is a special composition. That means that these two functions are inverses of each other. We haven't gotten into inverses yet, but we will throughout the year, and this is going to be a way that we can prove that they are in fact inverses of each other. All right, we did 4, 5, 6, and 7. Last one we're going to finish with is 8. So 8 is asking us to do, now we have 3 functions. So you have f of x is equal to 3x minus 2. You have g of x is equal to 6 minus 2x. And you have h of x is equal to x squared minus 4. Part A wants you to do 2 separate things. It wants you to find f of g of h, and it wants you to find f of g of h. Okay, so really important is you understanding what order this is going to take us in. All right, so this is trying to show the associative property. So if I move the parentheses from one place to the other, am I going to get the same answer back? So when you're doing compositions, you're always going to work at the end, and you have to start in the parentheses. So like this one is telling you that you're going to take h and plug it into g to start. All right, so we're going to do that one first. So we're going to take this h equation and plug it in to g. So we're going to get 6 minus 2 x squared minus 4. So that's taking this equation right here, and we plugged it in for x. Then we're just going to simplify, so we're going to distribute 6 minus 2x squared plus 8. And then we're going to simplify from there. Positive 6, positive 8, so we're going to do negative 2x squared plus 14. Okay, now it's telling you, it wants you to take that whole thing and you're going to plug it into f. So now we're going to take this whole thing and plug it into our f equation. So always working backwards. So we started inside our parentheses, we got that answer, and now we're plugging it into that f equation. So now we're going to have 3, open parentheses, negative 2x squared plus 14 minus 2. Distribute. We're going to get negative 6x squared plus 42 minus 2. And then simplify that down, negative 6x squared plus 40. That would be your final answer for the first one. Again, I know it's a lot of work, guys. I know that it's very confusing the first time you do it, so really work through it slowly and kind of try to understand piece by piece. Okay, so now we're going to do, that was this piece, now we're going to do our second piece, f of g of h. Okay, so starting with the parentheses and working backwards. So this g is getting inputted into f. That has to be your first step. So taking this g of x and plugging it in to your f equation. So you're going to have 3, 6 minus 2x minus 2. And you're going to simplify. So you're going to distribute your 3, 18 minus 6x minus 2, and then break it down. Negative 6x, and then 18 minus 2 is going to give us positive 16. Okay, this is where I think is gonna cause the most confusion. So really pay attention to what I'm saying here. So we did this piece first. So this piece is done, all right? We plugged G into F. Now again, the parentheses are gone. You have to work backwards, all right? So now it is telling you you're gonna take this H and plug it into the equation you just made. So you're taking this H value up here, this H equation, and plugging in here. So we're gonna have negative 6 x squared minus 4 plus 16. Distribute, negative 6x squared plus 24 plus 16. Combine together, negative 6x squared plus 40. That's your final answer. So then the last part, part B, is asking you, based on what you just did, what do you think is true about composition functions, all right? So based on what we did, a general statement we can make, again, this was all looking at, is it associative? So we can say that composition functions are associative. So you can move those parentheses and you can do the composition in different orders and you're still gonna work back and get your same final answer. Okay? Again, a lot of work. You really have to understand piece by piece. So again, always working inside out. If you're given this format, always working from the back forward. Okay? So kind of just keep that in mind. Y'all are gonna work through that homework. If you have any questions, star them. And then when we get back on Monday, we're gonna have that homework check. And then we'll have some chances to go through and kind of answer any questions you guys have on this lesson before we move into the next one, okay? All right, y'all have a great day. I will see y'all later.